Look up at the night sky. On a clear night you might see stars, planets, even a distant galaxy. But lurking among these celestial wonders are asteroids, remnants from the early solar system, hurtling through space at unimaginable speeds. Most are harmless, but some pose a significant threat to our planet. The Earth is not alone in this cosmic shooting gallery. Our moon bears the scars of countless asteroid impacts, a silent testament to the dangers lurking in the void. These impacts are a stark reminder that we are part of a dynamic and often chaotic cosmos. The threat is real, and the consequences of a large asteroid impact are potentially catastrophic. Imagine a force of nature capable of wiping out entire cities, triggering tsunamis that could inundate coastlines and even plunging our planet into darkness. But we are not defenseless. Scientists and engineers around the world are working tirelessly to develop the technologies and strategies needed to detect, track, and deflect potentially hazardous asteroids. We are in a race against time, a race to protect our planet and ensure the future of humanity. The Earth bears the scars of past asteroid impacts. These scars tell a tale of cataclysmic events that have shaped our planet's history, from the extinction of the dinosaurs to the formation of vast craters. One of the most famous impacts occurred 66 million years ago, when a 6-mile-wide asteroid slammed into the Yucatan Peninsula. The impact unleashed unimaginable energy, triggering wildfires, earthquakes, and tsunamis. This event, known as the Chicxulub impact, led to the extinction of the dinosaurs and paved the way for the rise of mammals. Scientists have identified over 190 impact craters on Earth, each a testament to the destructive power of asteroids. These past impacts remind us of the destructive power of asteroids. Understanding these threats is crucial for our future. In the face of this celestial threat, a global network of scientists and telescopes acts as our first line of defense, constantly scanning the skies for any signs of danger. These cosmic watchdogs are engaged in a relentless search for near-Earth objects, asteroids and comets whose orbits bring them close to our planet. Using powerful telescopes, both on the ground and in space, astronomers meticulously track the movements of these celestial objects. They analyze their trajectories, calculate their orbits, and assess the likelihood of an impact with Earth. The data collected from these observations is crucial for early warning systems and for developing mitigation strategies. One of the key instruments in this cosmic search is the Panoramic Survey Telescope and Rapid Response System, located in Hawaii. This advanced telescope scans the sky nightly, searching for any moving objects that might pose a threat. Another critical asset is the Catalina Sky Survey based in Arizona, which uses a network of telescopes to detect and track near-Earth objects. These are just two examples of the many observatories around the world dedicated to protecting our planet from asteroid impacts. The consequences of an asteroid impact depend on several factors, including the size, speed, and composition of the asteroid, as well as the location of the impact. Even a relatively small asteroid, if it were to strike a populated area, could cause significant damage and loss of life. Larger asteroids, those measuring several hundred meters in diameter or more, pose a much greater threat. An impact from an object of this size could release energy equivalent to millions of atomic bombs, causing widespread devastation and potentially triggering global climate change. The impact would generate shock waves, heat waves, and tsunamis that could devastate entire regions. The dust and debris ejected into the atmosphere would block sunlight, leading to a global cooling effect known as an impact winter. This could have catastrophic consequences for agriculture, ecosystems, and human civilization as a whole. The impact of an asteroid is a stark reminder of the destructive forces that exist in our solar system. It underscores the importance of developing strategies to detect, track, and deflect potentially hazardous asteroids. Averting Armageddon. The threat posed by asteroids is not insurmountable. Scientists and engineers around the world are developing innovative technologies and strategies to mitigate the risk of an asteroid impact. These efforts range from ground-based telescopes to space-based missions designed to deflect or disrupt potentially hazardous asteroids. One promising approach is the kinetic impactor, a spacecraft that would crash into an asteroid at high speed, altering its trajectory and steering it away from Earth. This technique, while seemingly straightforward, requires precise calculations and timing to be effective. Another option is the gravity tractor, a spacecraft that would use its gravitational pull to slowly nudge an asteroid off course over an extended period. This method, while requiring more time, offers a more controlled and predictable deflection. In addition to deflection strategies, scientists are also exploring methods for disrupting asteroids, breaking them apart into smaller, less dangerous fragments. This could involve using nuclear explosives or other high-energy sources to shatter the asteroid. The challenge of finding needles in space. Detecting and tracking asteroids is a daunting task. These celestial objects are often small, dark, and difficult to spot against the backdrop of space. They can approach Earth from any direction, making it crucial to have comprehensive coverage of the sky. One of the main challenges is the sheer number of asteroids in our solar system. While astronomers have cataloged millions of asteroids, many more remain undiscovered, lurking in the depths of space, waiting to be found. Another challenge is the diversity of asteroids. They come in different sizes, shapes, compositions, and orbits, making it difficult to develop a one-size-fits-all approach to detection and tracking. Some asteroids are rocky while others are metallic, and their reflectivity can vary greatly, making them more or less visible to telescopes. The vastness of space presents another hurdle. Asteroids can be incredibly distant, making them faint and difficult to detect. Even with the most powerful telescopes, finding these small, dark objects against the backdrop of billions of stars is like searching for a needle in a haystack. Deflecting the cosmic dart. Deflecting an asteroid is a complex engineering challenge that requires overcoming numerous technical hurdles. One of the primary challenges is developing a spacecraft capable of reaching the asteroid and delivering a sufficient impulse to alter its trajectory. The distance to the asteroid, its size, mass, and composition, as well as the available time to react, all play crucial roles in determining the feasibility of a deflection mission. A successful deflection requires precise calculations and timing to ensure that the asteroid is nudged onto a safe path and does not inadvertently pose a greater threat. Another challenge is the uncertainty surrounding the asteroid's composition and structure. An asteroid's internal structure can affect the effectiveness of deflection techniques. A porous asteroid, for example, might absorb some of the impact energy, making it more difficult to deflect. The development of deflection technologies requires significant advancements in spacecraft propulsion, navigation, and autonomous systems. The spacecraft must be capable of traveling vast distances, accurately targeting the asteroid, and autonomously executing complex maneuvers. Guardians of the future. The future of planetary defense lies in continued technological innovation and international collaboration. Scientists and engineers are constantly pushing the boundaries of space exploration, developing new technologies and strategies to protect our planet from asteroid impacts. One promising area of research is the development of space-based telescopes dedicated to asteroid detection and tracking. These telescopes, positioned in orbit around the Sun, would have an unobstructed view of the solar system, allowing them to detect and track asteroids with greater accuracy and sensitivity than ground-based telescopes. Another area of focus is the development of advanced propulsion systems that would enable spacecraft to reach potentially hazardous asteroids more quickly. These systems, such as ion propulsion or solar sails, could significantly reduce the time required to reach an asteroid and carry out a deflection mission. International collaboration is essential for planetary defense. Sharing data, resources, and expertise is crucial for developing a comprehensive and effective response to the threat of asteroid impacts. The price of preparedness. Investing in planetary defense is an investment in our future. While the threat of an asteroid impact may seem distant, the consequences are too great to ignore. The cost of preparedness is a small price to pay to protect our planet and ensure the survival of our species. The resources allocated to planetary defense not only contribute to our safety, but also advance our understanding of the universe and drive technological innovation. The technologies developed for asteroid detection, tracking, and deflection have applications in other areas, such as space exploration, telecommunications, and national security. Moreover, investing in planetary defense fosters international cooperation and scientific collaboration. It brings together scientists, engineers, and policymakers from around the world to address a common threat, promoting global unity and shared responsibility. Our place in the cosmos. The threat of asteroid impacts underscores our precarious existence in the vastness of space. It reminds us that we are part of a dynamic and ever-changing cosmos, subject to the same forces that shaped our solar system billions of years ago. As we explore the universe and unravel its mysteries, we gain a deeper appreciation for the fragility of our planet and the importance of safeguarding our future. The search for potentially hazardous asteroids is not merely a scientific endeavor, but a testament to our collective will to survive and thrive. The knowledge we gain from studying asteroids and developing mitigation strategies not only protects us from potential threats but also expands our understanding of the origins of our solar system and the conditions that led to the emergence of life on Earth. A call to action. The threat of asteroid impacts is a global challenge that demands a global response. It is a call to action for governments, scientists, engineers, and citizens around the world to come together and address this existential threat. We must invest in research and development, enhance our detection and tracking capabilities, and develop effective mitigation strategies. We must educate the public about the risks and engage in open dialogue about the best course of action. The future of our planet depends on our ability to recognize the threat, understand the risks, and take proactive steps to mitigate them. It is our responsibility to ensure that future generations inherit a world where the skies above are not a source of fear but a source of wonder and inspiration.